In this video, we'll be covering related rates, specifically focusing on a sphere. Now, air is being pumped into a spherical balloon at a rate of 4.5 cubic inches per minute. Now, if we think about that carefully, okay, if I have a spherical balloon and we're going ahead and pumping air into it from that base, again, that's the little notch of where you blow air into a balloon, it's going to fill up, but it's going to fill up and air is being pumped into it. Now, the air that's filling this balloon should revolve around the concept of the volume. Now, I'm going to write down this formula that's given to us right here, but we should really understand that this air that's being pumped into it is filling this entire balloon in regards to its volume. So the rate at which the air is being pumped into the balloon is dV dt. Okay, the change in volume over time is 4.5 cubic inches per minute. It says find the rate of the change of radius when the radius is 2 inches. So I want what is dr dt when r is 2. Now keep in mind, step 1 to every single one of these problems is I can identify all the pieces of information that I have, but then come back here and take the derivative, because we don't have a formula right now here that relates dV dt and dr dt, which is what we're looking for is dr dt. We have a formula that relates just volume and the radius. So I'm going to go ahead and take the derivative of this entire function. Very, very carefully, I'm going to take the derivative in respect to time. Okay, so ddt of v and ddt of 4/3 pi r cubed. Now, in this side right here, I'm just going to rewrite this as dV dt. That's what that's going to be. This side here may be appearing a little bit more tricky than you think it is, but 4/3 and pi are just numerical values. And remember, when I have a constant multiplied by a function of a variable, the constant can just be pulled out of the derivative. So I'm going to go ahead and show that step using the notation. So 4/3 pi ddt of r cubed. Now, when we look at this, I'm going to go ahead and think of what is the derivative of r cubed. Well, the derivative of anything cubed is 3r squared. And then don't forget that since we're taking the derivative in respect to time, I must take the derivative of just that r value. So dr dt. Now this is all multiplied by this 4/3 pi. I'm going to go ahead and put that in parentheses. I'm going to put that in parentheses. And this is equal to dV dt. So my next step is to simplify this up a little bit, and then again, I'm looking for dr dt. You'll notice there's dr dt in this formula. I'm given r, I can plug r in, and I'm given dV dt, I can plug that in. So you'll notice the only thing that's here missing a value is dr dt, which is what we're looking for. So I'm going to go ahead and plug all of this information in. My dV dt is 4.5 equals, and then I have 4/3 pi times, I have a 3 times r is 2 squared, and then dr dt is what we're looking for. So this is all multiplication. Now I'm going to backtrack for just a second here. I'm going to look at this one more time. If I read this one more time, air is being pumped into the spherical balloon. So when I add air to this balloon, you'll notice that it's going to increase in size. So the balloon's going to be getting larger, logically, which means that this makes sense to be a positive number. Let's talk about the radius. If the dr dt, if the air being pumped into it is getting more, that means that the radius looks like it's going to be changing from this one to this one. It's going to get longer. So it would make sense for my dr dt to be a positive number. If we don't get a positive number, it seems like we might have done something wrong. So let's go ahead and clean up this values right here. This 3 and this 3 are multiplied together, so I can cancel them out. Again, it's 4/3 times pi times 3 times 2 squared. So 3 on top, 3 on bottom, cancel out. That gives me 2 squared times 4, which is going to be 4 times 4 and 16. So I'm going to have 16 pi dr dt equals to 4.5. Now I'm going to rewrite this, instead of being at 4.5, I'm going to write it as 4 and 1/2, 4 plus 1/2. And then I'm going to go ahead and rewrite it so that it's a fraction, which I'm going to go ahead and find a common denominator, which is 8/2 plus 1/2, which gives me 9/2. So now when I go ahead and deal with this problem, I'm going to go ahead and divide by 16, and I'm going to divide by pi, because I want dr dt all by itself, and 16 pi is multiplied by that. So if I divide both sides by 16 pi, it's like I'm multiplying by 1/16 pi, which provides me with dr dt equals 9/32 pi. Now, I don't know what this number is off the top of my head, but the question is, like we said, is the radius changing in a positive sense? Well, this number down here might be a fraction, but it definitely is positive. So this seems like our valid answer. Now let's go ahead and get that unit down one more time. We'll read this one more time. Air is being pumped into the spherical balloon at a rate of 4.5 cubic inches per minute. So we know that dr dt and r are in terms of the inches unit, and because the time unit is minute, we can go ahead and say dr dt is inches per minute. And that finishes that problem.